Hello.
I had a question. I forgot to watch the Ed puzzle. Is that still, am I still allowed to watch that for a grade?
Yes,
Okay, thank you.
you're welcome. Just waiting for everyone to give everyone a chance to get in here. We have 17 right now, but I think there's more than that in the class. I think we have 19 in here now. I think we're just missing one. Let's wait just a little bit more and we'll get going. I love that Anya's outside. That's kind of cool. All right, I suppose let's get going. Who's ever missing can watch this as when I post it. So we are doing vectors again. Well, we'll be doing vectors for a few days. Oh, let me share the screen first. Still getting used to all this. All right, I have a dual monitor, so I'm gonna drag your videos off to the right over there. I think we need a calculator for this. I'm gonna grab mine anyway. If you're playing along, you might want to grab yours. I just want to clear everything. I want to clear just the screen. All right, here we go. This is section 8.2, day 1. We're going to bounce back and forth between 8.1 and 8.2. So we're in 8.1 today. We'll be back to 8.1 next time we meet. I believe there is a quiz on 8.1 and 8.2 on Friday. It's a short quiz that we have on like a Google form. So make sure you're looking at that for Friday. All right, here we go. Find the component form of vector AB with the given initial and terminal points. And part 2, find the magnitude of AB with the given initial and terminal points. So point A is -2, -7. 1, 2, 3, 4, 5, 6, 7. And B is 4, 1. 1, 2, 3, 4, 1. So here is vector AB. Find the component form. Vectors don't have location. So this vector here is the same vector if we move the tail to 0, 0. So now we just have to draw the same vector. Well, this vector has an x component. So that's 1, 2, 3, 4, 5, 6. 6 units to the right, and 1, 2, 3, 4, 5, 6, 7 units up. So this is the y component, which is 7 units. So now I just have to draw the same vector, but with the tail starting at 0, 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So those two are the same vectors. We don't consider those different vectors. Location doesn't matter with vectors. So this is the point 6, 7. So find the component form. So part 1 is 6, 7. But we don't want to count every time if we have some decimal values or some very large values. We don't want to count. Well, you just take 4 minus -6, 4 minus -6, and 1 minus -7. So 1 minus -7. So that is what? No. Oh, for crying out loud. I added right away in my head. Excuse me. 4 minus -2, which is 6. 1 minus negative. Did I count wrong? 4, 1, 2, 3, 4, 1. What? Oh, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, I counted wrong. 8, not 7. 8. So 6, 8 is the component form. I counted wrong. So that's one. So you subtract to find the component form, the x component and then the y component. Part 2, to find the magnitude or the length of the vector. Well, that's a right triangle. So we just use Pythagorean theorem. So the magnitude is equal to the square root of 36 plus 64. That is the square root of, oh, I made it nice, 100. So the magnitude for this one is 10. Magnitude, Pythagorean theorem. Find a unit vector with the same direction as the given vector. So the vector is 6, -2. 1, 2, 3, 4, 5, 6, -2 down here. And I'm going to cheat a little bit. There it is right there. A unit vector has a magnitude of 1. That's a unit vector, but going in the same direction as the given vector. So what you do is you divide each of these by the magnitude of the vector, magnitude of the given vector. So we want the square root of 36 plus 4. So there's the Pythagorean theorem on 6 and -2, and that is the square root of 40. So we'll call this 2 square root of 10, because this is 4 times 10. Well, now you divide each of these by the magnitude. So we have 6 over 2 square root of 10, comma, -2 over square root of 10. So we have 3 over square root of 10, comma, -1 over, oh, because I need a 2 here, -1 over square root of 10. Now that's the answer. That's the answer we're looking for. But now the rest is, well, what have we actually done? Well, first of all, if we do the magnitude on the vector we found, That's 9/10, because you square the 3 is 9, square that, that's 10, plus square these, and it's 1/10. Well, that's square root of 10/10. That's square root of 1, and I'll be darned, we found a vector that has a length of 1. It's called a unit vector, 1 unit. But if we look at the decimal values, 3 divided by square root of 10, almost 1, about 0.95. So this is actually 0.95. Now, everything in blue you don't have to do. And then 1 divided by square root of 10 is about 0.3. And you can see that if we go over about 0.95 and down 0.3, that little tiny vector there has a length of 1, but it's negative. It's also the same direction as 6, -2. So by finding this answer, we found a vector that's 1 unit long in the same direction as the given. But to actually get the answer, I think is very straightforward. You just divide each of these by the magnitude of the vector and maybe simplify a little bit. Pretty straightforward. But it's nice to know what you actually found. Let DE be the vector with the given initial and terminal points. Write DE as a linear combination of vectors I and j. Let's talk about I and j. I is equal to 1, 0. J is equal to 0, 1. So I'm going to go through this really kind of lengthy discussion of this, but this is a very simple problem as far as mathematically the steps. So let's get the component form of DE. And you do that by taking 2 minus -6 and 5 minus 0. It's like finding the distance formula, really. 2 minus -6, 5 minus 0. So the component form is 8, 5. So maybe let me tell you what the answer is first, and then I'll explain why it is. So the answer is 8i plus 5j. That's it. That's all there is to it. But why? So here's the why. I'll do a different color because you don't have to do any of this. It's 8 times 1, 0. There's the I. And then plus 5 times 0, 1. That's the j. Well, the way you do the operations on this, it's like the distributive property. So if we multiplied 8 times 1, 0, that'd be 8, 0. There's multiplying. Multiply 5 times this, that's 0, 5. And the way you add two vectors together is you add the x's and you add the y's. So 0 plus 8 is 8. 0 plus 5 is 5. So there we get 8, 5, but using I and j. This is the I, that's the j. That's it. So over here on this side is all you really have to do. But this is the whole process right there. If you got a question, go ahead and unmute yourself, shout it out. I'll get it answered for you. Any questions? All right, we'll move on then. Find the component form of V with the given magnitude and direction angle. So what do we have here? We have a vector that has a magnitude. Now, this is not absolute value with vectors. The bars means magnitude. Magnitude is 8 at an angle of 45 degrees. Well, here's the good news. If the magnitude was 1, then the component form would be square root of 2 over 2, square root of 2 over 2. If the magnitude was 1, if we were on the unit circle. We know a lot about 45 degrees. Well, if your magnitude is out here at 8, no problem. This is 8 times square root of 2 over 2, 8 times square root of 2 over 2. So both of them are 4 square root of 2 for this known angle. And so what you really need to know is its magnitude times the cosine of the angle, magnitude times the sine of the angle. So if we know the angle, if it's a known angle on the unit circle, we know the values. If it's not, if it was one off, it was 44 degrees, then we'd have to use our calculator and we'd have to do the cosine of 44 degrees and we get some decimal answer as long as I'm in degrees. I am. So that's the answer right there. There's the component form given the magnitude and the angle. Any questions? Find the direction angle of each vector to the nearest tenth of a degree. All right, well, this is the same way as writing it as -6, 2. So let's get an idea of what that looks like. 1, 2, 3, 4, 5, 6, -6, 2. So here's the vector right there. What do we need? The direction angle. Well, we have a right triangle right here. We can make a right triangle. And we really want this angle right there. But we're going to use what's called its reference angle. So if this is -6 and this is 2, then we know that the tangent of the angle in here, the reference angle that we're going to use, is opposite over adjacent. The tangent of the angle that we're looking for is opposite over adjacent. So to find the angle, we're going to take the inverse tangent of both sides, and that reduces to -1/3. So we grab our calculators, and we do everything with this in degrees with vectors. So we're going to do inverse tangent of -1/3. But the calculator thinks that it's in the principal quadrant. It thinks it is -18.43. Well, it's to the nearest tenth of a degree. So it thinks that it's over there. The principal quadrant is not quadrant 2. It's 1 and 4 for tangent. So we have to add 180 to this. So the angle that we're looking for is this obtuse angle, which is 161.5 tenth of a degree round, 161.6. There we go. Principal quadrants. Always have to keep those in mind. How about this one? Another one that's not a principal quadrant. These are kind of easy when it is principal quadrant, much easier. -3, -8. 3, 4, 5, 6, 7, 8. We don't have to be very exact here. We just have to have an idea of where this vector is. So the angle, excuse me, is always inverse tangent of y over x, -8 over -3. But that's going to be positive. So when we take the inverse tangent of 8/3, it thinks we're in the first quadrant. So it's going to tell us 69.4 degrees. So it actually gave us this right here, 69.4. But we want all of this. We actually want an angle that sits in the third quadrant. So again, we're going to add 180 to this. And the angle that we're actually looking for is 249.4 degrees. Quadrant 3 is not a principal quadrant either. So you have to get an idea. You have to know where the vector is so that when you use the calculator, you can actually give the correct answer. Somebody have a question?
Yeah.
Hey, go ahead.
So can you always just add 180 to the answer you get every time?
Well, not if it was 3/8 and I was in the principal quadrant. Then the answer would be 69.4. Does that make sense? Yep. Okay. All right. Rolling on. Oh, that is pretty much it. But we have about 12 minutes, so we're going to just practice a little bit more. I won't explain as much. I'll just go through the math and show you what you need to do for your homework. Find the component form and magnitude of AB with the given initial and terminal point. So the component form for AB on this is -6 - 2, and 9 minus -7. So that's going to be -8 and 16. So there's the component form for number 2. And then the magnitude of the component form is you just kind of finish. Really what we're doing is we're finishing the distance formula. So we have 64 plus whatever 16 squared is. So 64 plus 16 squared. And I don't know if your answers in your book are going to have this as a decimal or a simplified radical. So square root of 320 divided by, I don't know, 16. No, I don't know. Oh, yeah, look at me go. No, even more than that. 320 divided by 64. Oh, 8 squared of 5. 8 squared of 5. So here is component form. There's magnitude. It's really all it is the distance formula. Find each of the following for F, G, and H. So we didn't really cover this. I think this is pretty straightforward, so we'll just do an example here. So we need F, which is 80, plus 2 times H, which is -62. And it's hopefully it's exactly what you would think it would be. It's really order of operations. So it's like distributing, just distributive property kind of. -12, 4. So we multiply by 2, and then you add the x's and add the y's. So the answer, as we can see here, I even left the answers on a few of these. -4, 4. Pretty straightforward. Find a unit vector u with the same direction as v. We just divide each of these by the magnitude and maybe do a little bit of simplifying. So the magnitude is equal to the square root of 81 plus 9, square root of 90, Pythagorean theorem, of course, which is 3 square root of 10 again. Okay, it's very similar to the one I did before. So the answer we're looking for before we simplify is 9 over 3 square root of 10 and -3 over 3 square root of 10. So 3 over square root of 10, -1 over square root of 10. It's not always going to be square root of 10s, by the way. It won't always be that. And there's your answer right there. Let me know if I'm going too fast. Any questions? All right. What else we got? Let DE be the vector with the given initial and terminal points. Write DE as a linear combination of the vectors I and J. So remember, I is 1, 0, and J is 0, 1. So let's get the component form, -7 minus 9 and 2 minus -6. So that is -16, 8. So it's simply -16i plus 8j. Stop me if you don't get it. So find the component form of V with the given magnitude. It looks like I cut off magnitude. Given magnitude and direction angle. Magnitude and direction angle. So this is 4 cosine of 135 and 4 sine of 135. And we know 135 also. That's over here. Someone's trying to call me. Negative square root of 2 over 2, positive square root of 2 over 2. So this one is 4, -4 square root of 2 over 2, and 4 square root of 2 over 2. Oh, it's a scam. -2 square root of 2, 2 square root of 2. And I want to emphasize, if it's not something that we know, you're just going to type it in the calculator, get a decimal answer. So if it was anything, just slightly off of 135, I would just do 4 cosine of 134, and then we get that decimal answer. But if it's known, once we cover that unit circle, once we have known angles, we want exact values rather than decimals anytime we can help it. Find the direction angle of each vector to the nearest tenth of a degree. So this is, this component form is -2, 5. It's always nice to have at least a little bit of an idea of where this is. So the 2, 3, 4, 5. I just now know this is in the second quadrant, which is not a principal quadrant. So when we do inverse tangent of y over x, sine over cosine, that's what tangent is. When we type this in, inverse tangent of -5/2, it's going to give us the wrong answer because it thinks we are in the second quadrant down here. So here is your -68, 8.2 to the nearest tenth, and we just need to add 180 to that. So the answer we're looking for, there's the 111.8. I'm going to stop sharing. Everybody got that? That's playing along? Stop. I'm going to unmute everybody. Unmute. Oh, got a little bit of background noise, but mostly it's Anya with the wind because she gets to sit outside. She looks very cool. Any questions for the good of the cause? All right, we have an assignment. I need to put that up on Google Classroom. I don't have a spot for that yet. Of course, I would like you to turn it in as a PDF if you can get it to work. But if not, just take a picture and turn it in. And that'll be on Google Classroom. That's how we'll turn everything in. Any questions before we head out? All right, you guys, great to see you again. Have a good day. Stay safe, stay healthy, and we will see you again on Monday, right? All right, bye-bye. See you guys.